Okay, well, good morning, good afternoon, good evening, wherever you are in the world, and welcome to today's webinar. I see this is obviously a topic that's of interest. We had quite a number of people register for this, so obviously it's something of importance, and of course it should be. The subject being IEC61511 and Cybersecurity. As some of you are probably well aware, the standard was changed in 2016 to include cybersecurity now for the SIS. So the question then becomes, are your safety and control systems really protected? And we shall see. Again, just in case some of you don't know who we are, Exida, we've been around actually for nearly 20 years. Next year is the 20th anniversary of the founding of the company. And we've grown significantly in those 20 years, from starting off as a small company, assisting manufacturers with getting their equipment certified, to growing to providing one of the top tools in the world for doing lifecycle support services for IEC61511 and 1615008. We also now do cybersecurity certification for products. We have extended our certification to personnel certification as well, so you can become certified in cybersecurity, functional safety. And now we also have alarm management, which is now gives a certificate, as well as all the services to support those three. So we have full lifecycle services support for functional safety, alarm management, cybersecurity. Also, we've grown significantly globally, and we're in different industries and areas: automotive, steel, chemical, petrochemical, fertilizers, very, very diverse industries, but all with the same requirements when it comes down to safety and cybersecurity and alarm. How do we measure our success? Well, we're actually the leading certification agency now in the world for device certification. We've also changed the ownership from just the original two founders now. The reason being, of course, is they will eventually retire, but the company will still continue. We have over 100 global experts, probably close to 120 now, and in total staff, probably about 150 worldwide. We've done well over 1,000 certification assessment projects, and with the Excellencia, we've modeled well over 500,000 CIFs now. We publish a lot of books and reference material, and again, as I say to the classes that I teach, but also these webinars, is that there is a lot of information available through our website, exida.com, and quite a bit of it is free. We have white papers on various topics and subjects related to alarm, cybersecurity, functional safety, certification, and also these webinars themselves, which are free and are recorded and available through the resources section of the website. The SERH that you see there, which is the Safety Equipment Reliability Handbook, is available to be purchased through the online store, but also we have the Safe Automation Equipment List, which again is free, and it's through the website, and you can find certified devices by manufacturer and by type. So you can look for transmitters, pressure, temperature, different types of devices, fire and gas sensors, etc. All of that's available through the site, as well as the Site Safety Index, which is another tool to help you see how good your maintenance capability is at site. And then there's the SIL Safety website, SIL Safe Data website, which basically has, for final elements, actuators and valves, it has a range of failure rates that you should expect to see from manufacturers for these types of devices. And the reason that's there is because there's been an issue and problem with certificates having extremely low failure rates which do not match up with other industry databases such as IRIDA or PERD. And we've done that because our advisory board asked us to do that. And these are end users. And the end users are concerned that these certificates are still out there. A little bit about me, those of you that haven't been on one of my webinars or courses. I've been around in industry now for about 42 years. I started off designing control systems and then safety systems, fire systems, addressable fire systems, fire and gas systems. And I've been in the controls industry all this time. I'm one of the primary trainers for functional safety here at exida. I also do cybersecurity training as well. And I've written a number of papers, and I'm right in the process of trying to finish off a book for managers, functional safety for managers, what managers need to know, and hopefully that will be available by the end of this year. So that does with the introductions. So let's get to the nitty-gritty. So are your SIS and BPCS systems really protected? So what's been happening? This is an interesting question, because if we look at what's been happening, we can see that in the last 10 years or more, there's been an exponential jump in cyber security issues, and malware being one of the primary causes. For example, some of you may have heard of the Wannacry and the NotPetya, which was devastating. It caused huge amount of problems. And currently there's about 250,000 malware threats created every day. I mean, that's staggering, every day. There are tools that can help with this, of course. There's Norse. These can even track these attacks in real time. But nonetheless, the reality is that this is not going to get any better. The malware is only going to increase more and more, and people and particular nation states as well are trying to develop more aggressive types of malware. So what does this mean for OT? And OT, of course, when we talk about OT, we make the distinction of operational technology versus informational technology. Operational technology applies to the process control systems, networks, everything below the DMZ. And this is an area that has also grown in vulnerability and attacks, and especially from ransomware. And of course, the way ransomware works is it spreads its net as far as possible and attacks not just companies targeted, but also indiscriminately, because some of these can morph and can end up, in fact, affecting organizations or industries that it wasn't originally designed for. And these are accounting for about 60% of all cybersecurity attacks right now. So this means that your SIS and BPCS are not immune to ransomware. So you need to take steps to protect them. So if we look at this, the process safety case, of course, is now if we have SIS and BPCS and we're connecting them via a network, or there's even if it's air-gapped, there are potentials for loss of control, loss of visibility, loss of safety. So not only can we lose business functions at the IT level, we could have our patch servers affected. We could lose maintenance functions if you've got a maintenance server. Process conditions won't be able to be looked at and monitored in real time. If the BPCS engineering workstation is compromised, then that can get into the application of the basic process control system itself. And of course, if the basic process control system is compromised, and that can lead to unwanted events very easily. But if the SIS and the BPCS are both compromised, then this could have potential catastrophic effects if there is an attack aimed at those two. So there's plenty of ways in which the system can be attacked, and of course it will have an impact on overall process safety. So the two are not separate, they're very closely interrelated. And the pathways into the control network, as we know, there have been instances where there's one example where a plant manager at the weekend wanted to see what was happening inside his system. They'd just made some changes to the application and he wanted to see how it was going. So he used the virtual private network, which is a dedicated communication, and it has very strong authentication for you to get connected. And he used that to dial in and connect remotely into his control system. But the thing he didn't realize was that the night before, his kids had used the laptop to download something from the internet which was infected. Now, the thing about VPNs is, yes, there's sophisticated encryption, if you like, to get into the system, to get into the network. But once it's open, it's a straight through path. There's nothing in between to protect it. And of course, with him using his credentials to get into the virtual private network, he just transferred the virus straight into the control system without realizing it. And it took them quite a few weeks to find out what the problem was, because the control system started behaving in a fairly unpredictable manner. And they eventually traced it back through the historian and found that after he had logged in, things started to happen. And so when they went back and checked his machine, sure enough, there it was. So infected laptops can easily do that. Infected thumb drives can do that. So you need to be aware of where all these links is. And also in old systems, or systems, networks that have been there for a while, may have modems that are still connected but are not used, but they're still connected. There might be network interface cards in old servers that are connected but not used. So that's why it's very important to know what you have connected to your network and understand how these pathways can happen. Now, what are some of the myths? And this is classic. Even now, people still think that cyber attacks are only a concern for big companies. But let's not forget, cyber attacks can be both external and internal. And no one would want to target my facility because it's too small. Well, again, you have to think of the internal. The other one, which is a classic, is security was handled during design. So they expect the automation contractor to deal with it. So again, it's an assumption. I see there's a question, is what is a DMZ zone? So DMZ is what's known as a demilitarized zone. There's particular models that are used, and basically the fundamental one is that there are 4 normal zones. There's an enterprise zone, which is top level. There's a buffer zone, which is called a DMZ, demilitarized zone, where you would probably have your historian, you might have some of your servers, antivirus servers, batch servers, virtual servers in there. And then you, below that, will have your control zone, and then you might have a safety zone. And these are usually separated by firewalls and some form of protection. Now, if you want to know more about this, we actually have a training course coming up in the UK, which I'm teaching on the 29th and 30th of October, and seats are still available. So if you're interested, please contact Ali. She'll be happy to help you out. So coming back to what I was saying here about security was handled during design, the automation contractor, again, he can make sure that his control system is hardened and maybe even firewalled by using, usually they have a proprietary device to do that. But that's only one piece of it. The whole network needs to be looked at. And switches, the other classic is that switches are left in default configurations with default passwords. which means if you've got a 16-way switch and you're only using 8 ports, if you don't switch off the other 8 ports or disable them, they're open. So somebody could come along and stick an RJ45 in there and infect it. And here's another classic. My system is totally secure because it's air-gapped. Well, again, even if it's air-gapped, you've still got to program it. You've still got to probably have some visual means of seeing what's going on, maybe. And you may have antivirus in there. But again, antivirus is probably only 35 to 40% effective because it's blacklisting. And again, there's a difference between blacklisting and whitelisting. Blacklisting means you have to list everything that you want to disable or not allow. And whitelisting is you only allow these programs to run. So whitelisting is the best way to go, and that's typically what a firewall will have. Firewalls will have some rule sets which will only allow certain things through. And the other one is security by obscurity. And I'll give an example. We were asked to go and do a gap assessment, do an assessment of a site. And this site was way up northwest of the US. To get to the site from the road was a sort of a dirt track which was three miles from the road, and then there was a cabin. And when you got there, you went. The drivers would go into the cabin. There would be a console, and they would just enter what they were picking up or delivering into the console. Well, on the wall was a switch, and through that switch, we were able to get access to the worldwide network of this company, which you can imagine caused a lot of concern when the report was seen by the board of directors. So don't think because something's in the middle of nowhere, it's not going to be potentially open to problems. So these are the myths that still prevail, and they need to be understood. Somebody's asking if a firewall is enough for cybersecurity or more needs to be done. Of course, more needs to be done. And again, that's what we go through and explain what you need to do. There's more than that. There's policies, procedures, training. There's all sorts of things that we need to do. So what's the reality? Well, according to Kaspersky Labs' report that was done in 2017, where they said 54% of ICS industrial control systems have experienced attacks between 2016 and 2017. So in a 2-year period, 54% of all the ICS have had some form of attack. Now, if you think about how many control systems are out there, that's a huge number. And even now, many automation systems are still open to cybersecurity threats, because of some of the myths and some of the misbeliefs. And unfortunately, even now still, 3 years after 1511 was updated, very few organizations are actually ready to respond to cyber incidents. And there are sophisticated tools which are available for unskilled attackers. So if we look at the significant incidences that have happened, if you go back to 2000, there was the Marushi Shire wastewater treatment plant incident. But that was a single incident that occurred in 2000. And then the next major one was the SQL slammer, which impacted the offshore oil platforms in 2003. And then you see we go up to 2007, and of course the pivot point was the Stuxnet virus, because that's when it showed that you could really get into a control system and cause major problems. And what's happened now is the Stuxnet has become a blueprint, and through the dark web for these attackers to actually create the malware to target. And then if we move forward into the next 10 years, you can see what's happened. There was really, it was 2015 where things began to pick up, and 2016 and 2017, where 2017, NotPetya, the wiper virus, came out, and that was really bad, and Wannacry ransomware. So you can see that there's been a huge pickup. So we are witnessing now a period where there's intense increase in the number of ransomware attacks. And even some ransomware now is so sophisticated that I knew of somebody that their company had been hit with a ransomware. And there was a website that they could go to with an online help to tell them how they could pay the ransom using Bitcoins. It's got to that point. And the trouble is, if you don't pay up and you've got no way of being able to counteract the ransomware, then you could end up losing all your data. So the NotPetya, this was a nation-state wiper worm that was developed by Russia to target the Ukraine. They wanted to cripple the Ukrainian infrastructure. And it actually, the point was, it was looking at compromising and exploiting, actually, a backdoor that was in the accounting software, MEDoc. So it got in through the server and the backdoor into MEDoc. And it used a combination of the Eternal Blue, which is a self-replication, and the Mimikatz, which is another worm that extracts passwords that are stored in memory, to rapidly spread worldwide. Well, it did that. It went beyond just the Ukraine. And in fact, it hit the US and hit a number of US companies. And the cost is astronomical. This is the cost of it. The estimate is about 10 billion. And this comes from an article that Andy Greenberg published, The Untold Story of NotPetya. So you can see this is absolutely astounding. And these are very large companies, of course. So NotPetya was fairly insidious, and it did attack these companies. So this is why cybersecurity is important. And of course, if we look at it fundamentally, we know that modern SIS systems and basic process systems can communicate through process control networks. The advent of Ethernet and commercially available off-the-shelf, these open standard protocols have vulnerabilities. And these are the vulnerabilities that are exploited. So if you compromise your SIS via a cyber incursion, that can have drastic effects, because now you've got no automatic safety functions at all. And here, from the management point of view, we shouldn't be nostalgic. We need to be looking at how these things can work. The drivers, of course, are the use of commercially available off-the-shelf technology to make it more plug and play and make it easier to obtain. Remote access is something that needs to be considered very carefully, and how you lay out your network systems is also very important. And this is where, as I said, following one of the models, using a 4-layer approach and understanding what zones and conduits you have, how data flows, what needs to flow where, does it need to be bidirectional, can it be unidirectional, all of these things have to be clearly understood. So this is what I was saying, industrial automation control, cybersecurity. If we look at this, 20% is intentional, but 80% is unintentional. So what do we mean by unintentional? The unintentional we categorize into the fumbling, bumbling, and stumbling. The example I gave you of the plant manager infecting his control system, that was unintentional. The other thing is, if people take their mobile phones and plug them into their workstations to charge them, there again, mobile phones are probably the most easily infected devices. They can transfer into the system. infected thumb drives, of course, it's another one. So those are unintentional. And it's usually malware that's been introduced. The person is unaware that the malware is there, and they inadvertently introduce it into the system. On the intentional side, of course, the majority here is the disgruntled employee. The Shamoon virus that attacked Saudi Aramco and took down 30,000 machines, that was through a disgruntled employee. So again, as I said, policies and procedures are very important, but also making sure that access, physical security, is implemented as well. So what is automation cybersecurity? As I've said, what we're looking to try and prevent is the intentional or the unintentional interference with the correct operation of the systems, not just the control systems, but if you've got manufacturing systems, and of course, with the advent of the industrial Internet of Things now, a lot more wireless communication is coming through, use of networks and computers, of course. Operating systems, we know Windows has all sorts of vulnerabilities, and there's always patches coming out on the Windows environment, and other applications and programs. So that it goes by a number of different names. You know, people call it SCADA security, PCN security, etc. The term we use at Exida to incorporate all of this is Industrial Automated Control Systems, IACS. So we talk about covering all of these through Industrial Automated Control Systems. So we talked about IT and OT, and there is a difference, a fundamental difference between IT and OT. The priorities for the OT side of it is always availability. The process has to keep running, the plant has to keep producing, refining, etc., whatever it is. Availability is one of the top priorities. Then it's integrity, and finally it's confidentiality. Whereas on the IT side, of course, which is looking at the enterprise network, looking at the corporate side of things, confidentiality is the primary goal. Then it's integrity, then it's availability. So, for example, if IT suddenly decides to patch or to update antivirus, and I had this at my last company where I worked, I could be working on my laptop and all of a sudden a message would pop up to say that my antivirus was being updated. And of course, we all know what happens when that occurs, is that everything slows down because it takes all the processing power, which can be very irritating. So you have to go off and have a coffee or whatever. But you can't do that with a control system. You can't suddenly decide to patch a control system or do the antivirus updates, because if it goes wrong, and it has happened before, if the patch doesn't work or the update doesn't work, then you lose email, for example, from the enterprise side of things. Again, irritating, but it's not the end of the world. If you do that to a control system and you lose the controllers, well, that is the end of the world, because now your availability has gone to nothing. So these priorities need to be clearly understood, because there are conflicts at times between IT and OT. It's very important that the two work together when it comes to looking at not just the enterprise, but also the operational side. But understanding these fundamental differences is important. Now, what are some ICS vulnerabilities? Well, of course, we mentioned already commercially available off-the-shelf technology and protocols. So when you're using Windows, some SQL, TCP/IP control systems are now vulnerable to the same viruses that attack those, like worms and Trojans, that affect IT systems. Enterprise integration, again here, if you're using the plant, corporate, or even public networks, then you've got potential problems with process control systems that are being subjected to the same stresses they weren't designed for. Now here again, this is another reason when we get asked to do vulnerability assessments on live networks, we do not do penetration testing. This is one thing that needs to be clearly understood, because penetration testing is intrusive. It's deliberately designed to slam the network And the trouble is, some of the older devices that weren't designed to cope with that sort of intense communication can behave very unpredictably. And there was a case where a contractor was asked to go in and look at a SCADA system, and he did penetration testing on the network, and the RTUs started to fall over. They started to fail, lock up. And it actually caused tens of thousands of dollars of damage to equipment as a result. So you don't do that. Remote access, again, 24/7 access for engineering. And here again, some of the control system manufacturers will have embedded web servers. Now, sometimes you don't know that the web server is still there or even active. And this allows them to gain access. In fact, some of them say you have to connect to the internet to download the configuration information. So these are all potential vulnerabilities. Public information, there are manuals on how to use the control systems and publicly available password. There's websites that will give you the base IP address for some of these devices. There's other websites that will give you the default passwords. And it's not illegal to do that. Of course, it's illegal if you use them to access, but you can do it. So we know that the current standards, 1508 was updated in 2010 to include cybersecurity for devices, and 1511 was updated in 2016 to include cybersecurity for SIS. So again, how do we try and prevent these vulnerabilities from affecting us? As I said already, OT and IT need to work together as a team. They need to think about the assessment of the facility for inherent risk, and then design how you're going to design the right countermeasures. And you approach this as you would do if you were doing a safety review, a PHA. If you're looking at process hazard analysis, you do the same thing here from a cyber point of view, except it's not a hazard now, it's a threat. And then you look at where are the vulnerabilities and what are, in safety we look at layers of protection. In cybersecurity, we look at how we can mitigate that through the countermeasures that we can put in place. So, as I mentioned to you earlier, functional safety and cybersecurity are not different. They need to be looked at the same thing in the same way. So we need to understand the environment and the security requirements. So, for example, we should not have the engineering workstation with the, as I've seen, the password laminated nicely to the side of the machine. It needs to be locked away. It has to have access by the person who is allowed to have access to it. So there needs to be not just physical, but there needs to be some digital security. Understand how the systems are laid out, the architecture of the network, look at from a zone and conduit specific requirement, and then look at how you would assign security levels. And of course, this relates to the IEC61511 to help. But 1511 itself, was clause 8.2.4, talks about doing this security risk assessment. And it talks about the description of the devices that are covered by the assessment, SIS, BPCS, or anything else connected to the SIS. What are the identified threats that could be exploited in these, including both intentional attacks on the hardware and application programs, as well as the unintended from human error. Then a description of potential consequences. So again, what's the consequence of compromise if the SIS is compromised? Well, that would be a failure on demand. So we could end up with, if the BPCS is compromised and the valves are opened, control valves are all opened, which could lead to the SIS having to perform an automatic shutdown. Well, if that's compromised, then that's not going to occur. So you could end up with significant consequences. Look at the various phases. Same thing. There are the same three phases for cyber as there are for safety. There's an analysis, there's a design, and there's an operation and maintenance. And what are the requirements for additional risk reduction? Here again, you would use the current tolerable risk as the guide, and then what references. Now there are additional notes which, again, some people don't always read. So there's guide in how you assign the security in the TR8409, for example. And then note 2 talks about information and control of boundary conditions needed. And you'll notice here it says that typically with the owner operating company of a facility, not with the supplier. So you cannot rely just on your supplier to do it. There's some more questions here which I will get to in a minute. So where it's the case of complying with 8.24, this has to be with the owner operator, not the supplier. And then risk assessments can be included in the overall process automation security risk assessment. And again, the SIS security risk assessment can look at single CIFs to all the SISs, depending on how big the facility is. But this is the important thing. End users are responsible, not the automation supplier. And the reason is that the automation supplier will know their equipment very well, but they won't necessarily know the other equipment or the network itself. So you need to organize for security. And here again, it comes down, as in safety, it's all about the culture of the management and how they view this. Do they view this as a tax, or do they view this as securing their investment? And of course, the right approach is to view it as securing your investment. But it won't be achieved without support from the highest levels. You need to then communicate the goals to the stakeholders, and there needs to be clear definition of roles and responsibilities. As I said, IT and OT, there needs to be clearly defined roles, and they need to cooperate. So there needs to be a team made up of the management, the IT, the operations, the engineering, human resources, and finance. All of these people need to be involved. Then there needs to be a policy. So there's a formal policy that should be included that identifies the goals, the process, and the timing for this cybersecurity management system. Very similar to what we need to do for functional safety. There needs to be a functional safety management system. There needs to be a cybersecurity management system. And they could be included in the same document, just different sections. You need to communicate these expectations to employees. There has to be what we call cyber hygiene. People need to be responsible and to understand that they too have a role to play. It's technology independent, and policies outline what you want to achieve rather than how to do it. Your procedures and standards help you address the how. And of course, similarly with 1511, 1508, 62443 is also a performance-based standard and performance-based requirements. So you need to outline what you want to achieve. It needs to be independent of any technology. And of course, we need to document responsibilities. Who's responsible for maintaining what and monitoring what? We need to document how policies are enforced. So if you have a policy and somebody violates it, there needs to be a consequence. So that needs to be enforced. How are you going to manage these policies and procedures? And of course, this evolves over time. You need to document any exceptions and of course, what the expected incident response is when problems occur. So in other words, you need to have some form of disaster recovery if you get hit. And here again, the problem with the NotPetya was that if you have online storage and backups, they can be infected as well. So it's very important to have backups that are not connected to the network and that they are separate. And then you need to document how you're going to monitor this compliance. So what does this call for? It calls for developing an appropriate set of key performance indicators that you can use to measure. Because what we need to measure is, of course, number of cyber incidents, whether they're accidental or deliberate. We need to see how often are we doing periodic vulnerability assessments. And again, the 62443 talks about periodic, doesn't give you a defined period of time. You can set that. Policy violations, if any, occurred. How much training or personnel assessments. One of the things that's encouraged now is that HR gets involved to do profiling, because what you don't want is somebody who's going to get extremely upset and do something silly like happened with the Shamoon virus. How often are we doing patches and antivirus updates? And then audits. How often are we doing audits or assessments, carrying out the equivalent? In safety, we talk about functional safety assessment 4, which is the periodic assessment during operation. The equivalent in cyber is a CSA 4, which is a cybersecurity assessment for periodic assessments. And then 5 is if we need to make any changes. So, just to come back to this, we have to understand that the cybersecurity incidents are reality. It's going to get worse, it's not going to get better. And that even if it's not deliberate, there's always the prospect of an unintentional incident. So that's why it's important to have policies, procedures, training for people, talk about cyber hygiene. Don't plug your phones in to charge them. Don't bring in thumb drives from outside unless they've been properly screened, etc. The SIS and the BPCS, as we know, are critical to a plant safe operation, and if these are compromised, then this can have disastrous effects. And developing the right culture is vital in the successful implementation of both cybersecurity and functional safety. So in other words, the employees should be encouraged to speak up if they see things that are not happening correctly. And this also has to apply to any contractors coming into the facility. They have to be subject to the policies and procedural requirements from a cybersecurity point of view and should be vetted accordingly. Then developing the right set of metrics to be able to measure and assess the performance and see are our measures working. Simple things like locking cabinets with switches in or with the engineering workstations in, making sure that people can only have access to what they need and use the minimum amount of allowance. Look at the employees regularly and do the competency assessments, and then record all the maintenance activities accurately and faithfully, so that you can use this when you do a re-evaluation of the cybersecurity, the countermeasures you have in place, and the potential threats. And this way, if you do this and you follow a cybersecurity management system, then you can make sure your systems are as secure as they can be according to current best practice. And as I said, if you are interested in learning more and getting some training, we do have this course running in Warwick on the 29th and 30th of September. So if you're interested and you'd like to join, please contact Ali. I hope you found this useful and interesting. If you want to know more, by all means connect through our social media, or you can get me on my email address, which is sgandy@exida.com. Happy to answer any questions. And with that, let's see what questions there are. So, okay, let me see what we have here. Quite a few. So one question is, let's see, let's come back up.